So here I'm setting up my Arduino and breadboard. I'm connecting the 5-volt power to a positive pin and the ground to a negative. Then I'm connecting the HC SR04 ultrasonic sensor directly into the breadboard. And then I'm connecting VCC to a positive pin, which then connects to the 5-volt power source. Then trig to pin 9, echo to pin 10, and then ground to a negative pin, which connects to the ground on the Arduino. So here we're defining the trig and echo pins as pin 9 and 10, and then we're defining the integer, variable, and long variables. And in the void setup, we're defining the trig pin as the output and the echo pin as the input. And this just defines that the serial communication can start on the serial monitor. And in the void loop, we first have to clear the trig pin by putting it on a low state and delaying by 2 microseconds. And here is where we generate the ultrasound wave. This is done by setting the trig pin on a high state for 10 microseconds. Here we're defining how to read the travel time by putting it in the pulse in time. We put high here so that the pulsing function will wait for the pin to go high and then start timing, and it'll stop timing when the pin goes low. And to get distance, we multiply the duration from here by 0.034 and divide it by 2, and this is because the speed of sound is 343 meters per second, which we convert to 0.0343 centimeters per second. And this last section here is just defining to print the data on the serial monitor. So this is an image of the setup. You can see that the tape measure has a flat surface behind it, which is, I'm using like a pencil box. And here is the code, and to get it to run, you do tools, serial monitor, and this will display all of the data. So you can see it's around 10 centimeters away right now. And then when you move the box back to 8 inches, which is around 20 centimeters, the serial monitor will display 20. So this part of the video displays the actual me running the experiment. So you can see every time I move back 10 centimeters, it is displayed back on the serial monitor. I did this for 3 trials, and I took the average of these results and made regression lines with them, and then used the average slope of those in the adjusted code, which you can see in the report. I did try to complete this on a longer surface, the 4-meter distance on the floor, but the surroundings kept getting in the way, and it seemed like the further away it went, the results weren't as accurate. And I think this is just because I didn't have an ideal environment for it, so I thought a better idea would just be to do it on the 110 centimeter table I had and get more accurate results that way. So for the remainder of the video, you can watch me complete my first trial and test every 10 centimeter increments up until I finally reach 110 centimeters, which is the end of the table. And then like I said before, I completed this 2 more times and took an average of all of the trials.